Good evening, ladies and gentlemen. Welcome to the second of our series of webinars hosted by the Hereford and Worcester Centre from the West Midlands branch of the Institute of Physics. Now, as this is a webinar, those of you who are attending will not be able to speak or be seen. So you're quite free to get up to whatever you want to in front of your camera. If you want to ask a question, there is a question channel which is available to you. And at the end of the talk, Margaret and David Cross will curate your questions and will ask David the questions. Now, for some reason, I was supposed to be showing you a slide of my computer program, and my computer's gone completely to a pile of whatever. So at the moment, I'm going to, I can't even get up control back. Hopefully you can see me now. So I will get straight on and I will introduce tonight's speaker. So David Wilkinson graduated in physics with medical applications in 2001. He then spent 6 years working as a government scientist, mainly in the Home Office, police, weaponry and drugs detection programs. But in 2007, he moved to the Institute of Physics and he became our Midlands regional manager. And it's a real privilege to have David working with us. He's now chartered physicist, and he's a visiting fellow also at Nottingham Trent University and a senior fellow at the University of Lincoln, which is something I didn't know. He's a science fiction novelist, and his first novel called We Bleed the Same was shortlisted for the 2015 East Midlands Book Award, and he now has a second book, Under the Shell, which was published in 2018. So I'm going to hand over now to David, and we're very much looking forward to hearing his talk.
All right, hopefully, John, can you see my slides now?
I can see you. Yes,
and you'll also see that there's closed captioning at the bottom. When I say certain words, it's going to probably not do very well with them, like Asimov. Oh, we got that one. That's good. Right, okay. So a couple of words before I start. Firstly, thank you very much, John, and everybody else for inviting me along. It's absolutely great to be here. And the other thing that should be noted is that this is very much a personal take on science fiction. So I'm only covering books, okay? So we're not heading off into Star Trek, Star Wars, or anything like that. And it's very much a history of my personal tastes in science fiction. There's a couple of shelves in the next room, absolutely stuff full of the stuff. The other thing I need to think about at the moment is a little disclaimer. So all statements about works featured in this lecture are personal opinions and take the form of a review of the content and materials. Firstly, that's because some people might not actually agree with what I'm doing. And the second is that I also checked up on the copyright laws about showing you pictures of all these books. But it is fair dealing for criticism, review or quotation allowed for any type of copyright work. So we're all good there. Another thing I'll point out to you is that in the side pane, you will be able to find a handout, which is the, there's one that's the Hereford and Worcester programme, but there's also another one, which is a reading list of all the books that I'm going to talk about today. So you'll be able to actually find those and read them and see if you agree with me or disagree with me. So I've broken it down in that reading list into the different topics. So you'll see the same book popping up again in different areas, but it's all been arranged by topic. So let's have a think about science fiction for a moment. It's often regarded as not as highbrow as other forms of fiction, and a lot of people think that there's flying saucers in there, or even more bizarre things, and I have to thank my wife for finding that one for me. So that's the Wonderful Planet of the Knobheads by Stanton A. Kublentz. It's an interesting book, to say the least. and has multiple physics problems that I'm not going to go into now. So where do I start? Where did I start with science fiction? My first science fiction book was Spaceship Medic by Harry Harrison, but that's a lie. My first science fiction book was The Amazing Journey of Spaceship H20 by Richard Fowler. And it's this wonderful book. If any of you have got children or grandchildren of a young age in your lives, it's a fantastic one to get hold of, because you get this little spaceship that flies through the book. And so the main characters are, here they are, and the ship will actually take off and then disappear behind that flap. And then you open up the next page and it's there in the right place, ready to continue with the story. So it's a fantastic little book. It concerns the adventures of Chuck, Buzz, and Captain I'll Be Back Later, who are sent off to actually look into a problem where these people called the Cruels have taken over the planet, the frozen planet where all of the Earth's food is stored. And so they have to go off and try and rescue that. Now, I'm just going to take a second because I forgot to put up my notes. Never mind, I'll soldier on without my notes. Okay, so they are going out to find these Cruels and save the planet from it. So where's the physics in this? Well, in actual fact, at one point the ship arrives at this place called Planet M. Now, Planet M is a magnetic planet entirely set up to deal with the problem of space debris. So here we are, a book. It's a bit of an allegory about global warming, I guess, from the early 1980s. But the principal thing is that it's in this part of it, they're dealing with space debris. So what is orbital debris? It's any man-made object in orbit about the Earth which no longer serves a useful function. There are about 500,000 pieces of debris about the size of a marble or larger. And there's millions of pieces that are so small they can't be tracked. In fact, a lot of them are actually paint flecks. And there have been windows in the International Space Station that have actually been replaced because and the replaced window has been analysed, and it's actually been flecks of paint that have caused the damage to them, because these things can have impact speeds of tens of thousands of miles an hour. So our little force equals mass times acceleration equation from GCSE physics is causing those little problems. They travel at speeds of up to well, 17,500 miles an hour, but you know, if two of them are doing that speed and crash into each other, then the combined speed is quite a impact. I'm just going to, I really do need these notes, so hang on a second, please. I found these earlier. I'm using an unfamiliar thing. Hang on, please. Here we go, right. That's better. Right, I apologize. That will be the last time that I mess around with that. So here we go again. Right, so orbital debris. There are various things that people are now doing to try and deal with the problem of orbital debris. So in Spaceship H20, they're using a big magnet that's floating around in space, and obviously there's quite a few problems with that. But here on this chart, you can actually see how different things are coping with this. So these are high energy collisions in this darker color and low energy collisions down here. So if you just leave a spacecraft to decay normally in orbit, it will come down in about 700 years. If you actually plan for it to decay more rapidly, you can get it down in 100 years. But there are various other things we're trying to do. The international space community is trying to introduce a 25-year rule, so that all ships should come down 25 years, within 25 years of the end of its useful life. This is the basically a proxy for the chances of it causing damage. But there are other things in there as well. So things like an electromagnetic tether, the idea that if you put a large strip of metal out, the electromagnetic forces of the Earth will act upon that and slow it down. And you could also inflate things for an enveloped sphere, or you could have a grey gravity gradient tape. So this takes advantage of the difference in gravity between a high point and a low point. So when the satellite reaches the end of its useful life, you can extend these great big long strips, and that will help to cause the drag on it to push it back down to the Earth. So let's go back to these first science fiction books that I was talking about. So there's a couple here. One is called Wheelie in the Stars, and the other is called Spaceship Medic. Now, Wheelie in the Stars was written by a general novelist called Nicholas Fisk. I first came to him through other books, including ones about kidnapping and things like that, and read that one. And Spaceship Medic was out at the same time. And the interesting thing is the difference between them in the quality of physics that's inside them. So let's look at Wheelie in the Stars to start with. So this is a universe in which oil has been banned because it almost caused a war. And in the future, they have created an energy source called rad. Now, the problem is that there is no explanation as to what rad is. There are a load of balls. These are in spaceships. These are on planets and things like that. So these balls are the source of the power, whatever it is. They do not seem to take any account of the laws of physics in terms of light speed or anything, because all these rad things are in a network that work together, a kind of energy network, and it doesn't really explain anything. Another problem, it's an interstellar network, and it's susceptible to electronic interference. And one of the problems they discovered, so these two chaps that you can see there on that motorbike, they have smuggled in an illegal motorbike and are playing around with it. And the electronic interference from that motorbike screws up the rad system. It doesn't explain why only from old motorbikes, because I'm assuming there's a whole load of other electronic stuff around. So they have to go around to the other side of the planet on the motorbike, and in the end, the motorbike saves the day. I'm going to stop talking about Wheelie in the Stars now because it's fun, it's interesting. Various things happen in it that are kind of difficult and so on. But for me, it's an example of somebody who has completely ignored real physics in the production of the book. Both this book and Spaceship Medic are actually aimed at around, I would say, around 10 to 12 years old. So Spaceship Medic, much better indeed. It is about a ship in the near future when we have a standard cruise liner going to Mars and back again. And this guy, the Spaceship Medic, it's his first trip. He's the ship's doctor. And unfortunately, halfway to Mars, the ship is hit by an asteroid, and it smashes up the ship and kills all of the officers except for him and the chief engineer. And so the whole book is about him trying to get the ship to Mars and all the passengers safely to it as well. So what's good about it in physics? Firstly, it's a realistic journey time. It takes about 3 months for the ship to get to Mars. The second one is that it takes account of acceleration and deceleration. So it accelerates for the first half of the trip, and then it flips over and it decelerates for the second half of the trip. So there's no kind of like instant fast speed or anything like that. And it takes account of the fact that you need a slow increase in acceleration, otherwise everybody will be trapped against the back bulkheads of the ship. It notes that there is no sound in a vacuum. If two spacemen want to talk to each other, they actually have to touch their helmets together in order for the sound to travel from one person to the other. That's if their radios aren't working, of course. It deals with solar storms and how to deal with them, and I'll come back to that in a moment. It takes account of this idea of artificial gravity. So it talks about a rotation for that. It also does correctional navigation. So it notes that if you take time before you correct a navigational error, the force that you need in order to correct that error is larger than the force you would have needed at the start. And remember, this is a kind of short 40,000 word book for kids, and it's doing all of this. Reaction mass versus inertia. It takes account of the fact that in order to move forward in space, you need to throw something away rather than just squirting air that's already there. It takes account of communications delay and transmission. So the fact that they're talking to Mars means that there's a delay on the line talking back and forth between it. And there's even a character who is a mathematician, and he saves the day at one point. It takes account of electrolysis as a means of oxygen production. So all in all, this is a pretty good bunch of physics to be giving to kids, and I can heartily recommend it. However, it does fail on just one thing. He got so close in it all. Now, this is a kind of odd diagram, so I'll explain what it is. So they describe what the ship looks like in the book, and this is basically, as far as I can tell, what it looks like. And this is where everybody lives. This is the big rotating bit. So everybody's on the outer couple of decks of that and gets some gravity as a result. And this is the engine, and this is the engine room. And this is the situation when the solar storm happens. So when the asteroid has come in and crashed, they've lost lots of their water because they've got a great big water tank here on the ship. And the reason they have that water tank there, as well as supplying water for the ship, is that if there is a solar storm coming from this direction over here, the idea is that they turn the ship to face the solar storm, and then a great big water tank will absorb most of the radiation, the ionizing radiation that would hurt people. Now, in the book, they've lost so much water that this no longer works. There's not enough water to do it. And so they move all the people in the entire ship down to the engine room, which is just here and protected by the bulk of the engine. So everybody goes in there, but somebody needs to stay behind to control the ship and make sure that it stays aligned and facing the sun in that direction. And so, you know, the doctor decides he's the one to do it. And this is where it falls down, because he says, we just fill this room with water and then I'll be safe. And it doesn't take account of the fact that what makes this big tank of water safe is a sheer amount of it. You need about 10 meters of water to get rid of some of the radiation. When I went to visit Sellafield, they keep their radioactive rods in big ponds, but there's about 10 meters of water above them to absorb that radiation. So even when he's in this tiny little room with only about half a meter of water in front of him, it wouldn't really save him from that. So close. I'm going to let them off with that one, being as the rest of it was so excellent. So I've spoken about the artificial gravity going around like that as well, because this is a bugbear of mine, and I promise I'm not going to talk about TV and shows and all the rest of it, except to say that the reason everybody has artificial gravity and things like Star Trek is because it would have been far too expensive or look too shoddy to have everybody floating around. So it's far easier just to say, well, there's artificial gravity, and now we can film it really easily. But even people like Isaac Asimov can be a little guilty of it. You'll be hearing me talk about Asimov several times in this, because he has influenced a lot of the work that I've done in science fiction. So one of his characters says, this is one of the first ships to be totally graviticized. And this one made me put my head in my hand. What does that mean, says the historian, but please don't explain if it requires extensive physics. That's irritating to me, obviously. But the guy tries, he says, anti-gravity is the equivalent of non-inertia. There is no feeling of acceleration when velocity changes, since everything on the ship undergoes the change simultaneously. Thing is, that's as far as he gets in the explanation. So he's acknowledged there's a problem. He's addressed that problem, but he hasn't really used some proper physics to deal with it. So this is far more up my street in terms of artificial gravity. This is a book by Larry Niven and Jerry Cornell called The Mote in God's Eye. And so their ships are a combination. They have a combination. When they're in orbit or in free fall, then they rotate. So everybody can go to the outside of the ship and experience pseudo-gravity in a rotation way. But what they do when they are traveling is that they accelerate at 1g. So an acceleration of 1g is what drives them forwards. Of course, the problem with this is that what was the floor is now a wall. And so everything within their ships has to be able to be moved from, so that's your bulkhead, you put them on the back, that bulkhead and lock it all down. And then when you're ready to go, you stop the rotation, everything gets moved onto the other bulkheads, and then off you go and fly into it. Now, the thing is, with so in my first book, We Bleed the Same, this is the way that I have my ships running as well. The only thing they didn't really massively get into in that one is if you are fighting a battle, if you are changing direction, changing speed, and all the rest of it, especially if you're using like 1G engines and so on, then during a battle, the wall becomes the door, becomes the floor, becomes the ceiling very quickly. And so one of my characters actually has to cope with being rattled around in this ship. During the battle, they are smashing into this bulkhead and then smashing into that bulkhead. So that's what we're getting into with artificial gravity. So now I'm going to have a little think about good writing versus physics, because obviously you can get physically correct books that are terrible. and you can get really, really good books where the physics is terrible. And I've hit a particularly good vein of Russian science fiction recently. Three particular people I'm going to talk about now, but it's a good one for looking at. So the first is the Strugatsky brothers, Arkady and Boris. I'm going to look at briefly at three of their books. So these are three of their best books, and certainly ones that if you want to go and find them are good ones to go for. So Hard to Be a God is set in a pre-Renaissance context on an alien planet. So it's also one where learning is suppressed, and they basically ignore there being any science. So humans have got to this planet through some form of out of the book science, but then there's nothing addressed there. It's very much a thing about a lot of their work is about fascism and communism and the human condition, and examining that kind of thing. The second one is Roadside Picnic, which is often cited as one of their best books, actually. And in this one, the physics is in the hands of aliens who have visited the Earth. So the aliens have come to Earth, they've stayed for a couple of days, and then they've left. And the areas where the ships have landed are littered with all this kind of alien technology. And it's about somebody who's going out to try and find that technology and sell it. So all of the technology is unexplained. It's been created by people who are not in the book. And so it's there, but it's, again, a different way of not explaining. And then the third way of not explaining physics, because, again, this is, I say these are good, well-written, beautiful books without explanation. And this is the third one. And this is, for me, the most irritating one. This is one where the science is going to, you see, And if anybody reads this and actually figures out what the end means, I would love to hear from you, because I've been scratching my head ever since I read the end of this. I'm thinking of reading it again just to try and get my head around what they were trying to do with it. So that's three different ways of removing science from a science fiction book without destroying a good piece of work. Another good story is by Dimitri Glukovsky. So this is the Metro 2033 series. This is set in the Moscow Metro 20 years after a global nuclear, biological, chemical conflict. And so the people in the metro, it was designed as a big kind of air raid shelter. And the people down there, there's 20 years later, they're all living in this big metro system underground. And both that one and the second book, Metro 2034, are a bit weird. I mean, you can tell he had an eye on the fact that he wanted this to be a computer game when he wrote it, and these pictures are from the computer game that came from it. But you can see he's created all kinds of weird and wonderful creatures. That one there is actually supposed to be a librarian that lives in the Moscow State Library. And so there's all of these mutations are supposed to have happened within 20 years. It doesn't really work. It doesn't really explain either why, after a nuclear war, so much of Moscow is still standing and people are able to go up there and take bits out of people's flats and so on. So that was a really odd bit. And I enjoyed the story, but I was not buying anything in terms of physics. And then he wrote the third one, Metro 2035. It's about twice as big as any of the others, and it blew my socks off. It was a really, really good book. And I don't know if he was embarrassed by the early ones, but he's got rid of all of the creatures that are around. They've all gone. They're supposed to have just died out. And then he explains why the city isn't destroyed. And he talks about various other things. And the whole story actually comes back to a solid scientific basis. In order to truly appreciate the third book, you really do need to read the first and second ones as well. But I think it's well worth the commitment. So that takes us into the realms of dystopia, disaster, and anti-science kind of science fiction. So there's this idea that a lot of science fiction authors, people like Mary Shelley, Frankenstein, is suggesting hubris. It's suggesting that we are overreaching ourselves and ignoring ethics when we are talking about science. And so there's a large range of dystopian science fiction out there as well. An obvious one to start off with is 1984. It's a post-nuclear war world, well, obviously a limited nuclear war, but physics and science in that advances purely for military and surveillance purposes, new weapons, rockets, torture devices, telescreens, and things like that. So their ethics has gone out of the window, and science and physics has become the servant of tyranny. This one technically isn't about physics, but I'm including it, Margaret Atwood's Oryx and Crake, because it's one of the most scarily close to the world that we're in now. I think we are only a hop, skip, and a jump away from the world that she's predicting in that coming to pass. From the things like, if you've read it, the plebe lands, the fact that people live in ultra-gated communities, the difference between rich and poor, and the unfettered biotech kind of world that they're living in. And if you read it, you will never look at pigs the same way again once you have encountered the pigoons of Oryx and Crake. One of Isaac Asimov's early ones, Pebble in the Sky, is set on a world where the world is largely radioactive for reasons that aren't clear at the time. And I think the really interesting one, so he wrote it in 1950 in a world where we thought we could survive nuclear war. It was republished in 1982, and he wrote a retraction in the later edition saying that he was completely wrong. There is no way we could survive in that kind of world. Unfortunately, it was so integral to the plot that he couldn't really get rid of it without changing the entire book in its entirety. So it's one of the rare moments I've ever seen an author print a retraction about their own fictional work. Another one, it's a fairly obscure one, this one. I don't know if anyone will have ever even heard of it. It's The Reefs of Space from the Star Child trilogy. And humanity is so crowded. So this is an old book. This is from 1963. And humanity is so crowded that central planning has become necessary. There is now a world-encompassing computer that controls where everyone goes. There's full surveillance. People have to learn to communicate directly with the computer by singing to it. Now that sounds odd unless you remember, those of us who are old enough to remember dial-up modems when it went and all the rest of it. So that's there, and I think it presages the sound of the dial-up modem. The gods themselves, again, another Isaac Asimov one. He introduces the idea of an inter-universe electron pump. So we, with humanity and an alien species, have managed to create a small device that creates a wormhole between two different universes and takes advantage of the inherent differences in the laws of those universes. So the differences between them actually create an imbalance that allows them to drive a pump that creates unlimited energy. And the main reason I'll recommend this is that it's a truly surprising book. There is a twist in it about halfway through that is stunning, and I certainly never saw coming. And it's not the standard 3-act structure or anything like that. I think it's an interesting book to go for. Any dystopian collection can't go by without Fahrenheit 451. Technology used to control by design. You have things like avatars in there. And that leads on to one of the surprising ones, and I have to thank my mother-in-law for bringing this one to my attention. The Machine Stops, written by Ian Forster in 1909. It's only a novella. You'll get through it in about an hour if you read it. And it's set in a world where everybody is living in their own apartment. They never go outside. Everything is provided through basically an internet. And people have so retreated into their houses, does this sound scarily familiar at the moment, that everything is delivered to them, that nobody really understands anymore how the machine works. And it explores what happens. Well, it's not too much of a giveaway. It explores what happens when that machine stops. And there's even a moment, one of the main things people do in that to pass the time is to sit in their own houses and give lectures to people who are sitting in their own houses. And this was written in 1909. So that's a particularly entertaining little book, well worth getting hold of and having a look at his ideas in that. So we'll move into robots and AI. And normally when I've got a room full of people, I say, which writer coined the term robot? And I rely on some people to do a QI and shout Isaac Asimov. It's not Isaac Asimov. There are usually plenty of people, and I'm sure some of you are shouting it at the computer screen right now, which is Karel Čapek wrote Rossum's Universal Robots. Not only did he create the idea of the automaton, he actually coined the word robot itself. So in this, robots were organically grown androids. It was Asimov, amongst others, who adapted the idea to inorganic robots. But in Czech, robota means forced labour, of the kind that serfs had to perform on their master's lands, and is derived from the word rab, meaning slave. So you can see which way they're going with that. It is a classic tale of slave revolt and the robots taking over. So we come back to Asimov and robots and AI. The first iRobot is actually, you may have seen a film that is one continuous thing, but iRobot is actually a collection of short stories. The first robot novel is The Caves of Steel, and that's a murder mystery set on, again, a future crowded Earth, the kind that you would see in films such as The Fifth Element and even Coruscant on the Star Wars universe. The first story to contain the 3 laws of robotics, which are laws that I assume everybody here knows, but I'm just going to flash up. I'm not going to read them out, but these are famous laws, and they were created in a short story called Runaround, which was the first place that they were there as well. And this dealt with the idea of robots and artificial intelligence becoming better than us and then wishing to take over and deal with us. And so if you are a science fiction writer writing about artificial intelligence, you have to grapple with this. Is the intelligence benign, or is it going to try and kill us? And how much can we try to control that intelligence? It's something I get into in Under the Shell. So in these books, these things are supposed to be within the very DNA of the robot's brain. He doesn't say what that DNA is or how it is that you can't create a different brain without that in there. So I had to think about it and thought about, if you have a neural network type of brain that you're creating, but each of those cells had a small amount of processing capacity for itself, that's where you could put that kind of information. That's where you could say, never kill the humans. And so having put that in there, I then, of course, explore the idea that somebody has taken that program out of all of those, and there's a robot without any of those inhibitions running around. So AI can be shown as being benign, or a joint member of the universe with us. So in Ian M. Banks, The Player of Games is part of what is called the Culture series, and in that the artificial intelligences are part of the wider culture. So you have aliens, you have humans, and the artificial intelligences are equal players in that kind of environment. In Ancillary Justice by Anne Leckie, the artificial intelligences are usually huge things in spaceships, and then they have connections with lots of subsidiary parts, including these things called ancillaries. And so that is a kind of book where there is organic life is controlling things, but the artificial intelligences are very big and they're very there, and are more like tools. But it's exploring about when a tool becomes self-thinking. It's exploring about the agency that these kind of things can have. Of course, you can then also get into books that reject science and AI. So in The Bullet Catcher's Daughter, for example, by a friend of mine called Rod Duncan, he is in a world where science has created something terrible, and something called the International Patent Office now has to look at any new experiment, any new piece of equipment, and decide whether that stuff can actually be turned to military applications, and if it can, then it will be banned. It's called The Fall of the Gaslight Empire, and there's several books in that one. And of course, famously, Dune alludes several times to a period when humanity was enslaved by thinking machines, and so computers have been completely outlawed in the universe of Dune, and have been replaced by human computers, or mentats, who actually do the thinking for people there. Little fun fact, on page 227 of The Bullet Catcher's Daughter, there is a creepy Victorian doll who is named after me. It's one of the weirdest things ever. Right, so I'm going to have a think about something that I threw out there in one of my books at one point, called Anthropological Physics. Hang on, did I just make that up? Yes, I did. So it's in there, And I'm going to put these up as well. So I've now not only made up an entirely different concept that I'm going to talk to you about, I've had the temerity to put it up against some of the most seminal works in science fiction. So there's a character in it called Daruna Chandramogan, and she is a professor of anthropological physics. Now, physics is universal by its very nature. And although we're very used to, in the physics community, chucking around constants and making assumptions based on them, x is proportional to y once we stick a constant in. But we have to be careful of the difference between numeric constants and ones that are just assumptions. So foundation, humans are treated at the atomic scale. There are now so many human beings that one human being, you cannot predict what they're going to do, but many human beings, we can actually predict their direction of travel, the way they'll interact with each other and so on, the opposite of the great man theory of history. And at the end of Foundation and Earth, this book here, and I have to tread very lightly because I don't want to give spoilers, because I'm going to talk about something that happens in the last 3 pages of the 5th chronological and final book of the Foundation saga. But a character must choose between 2 futures for humanity, a second Foundation future or a Gaian future. And it's only when he realizes that certain assumptions that everybody has assumed are correct are incorrect, that he can make that decision. Now, anthropological physics, the physics may not be different, but an alien's path to the truth may be very different indeed. So what am I talking about? Well, let's compare humans to an imaginary underwater civilization. So to our Isaac Newton, the effect of gravity was clearly displayed by the falling of the apple. Now imagine an octopus Newton in an underwater civilization. She's surrounded by a world of buoyancy. Is it confusing to a primitive science that rocks will fall, but living things will float? Might that not lead you to the idea that until they die, it's in the nature of living things to float and dead things to fall? And so that way, the path to gravity maybe becomes trickier. I mean, NASA used flotation tanks to simulate a world of free fall. So what might Octopus Newton get to quicker? Well, human beings can watch birds on thermals. They can observe it from the ground, but not experience it. So an Octopus Newton can actually swim over to a thermal current and experience it for herself. So I'm not saying that we get to different places in the end, but I do say it may be that different environments will allow physicists in different experiences to get to places in different ways. Explaining physics of the thermal current, of course, may prove harder to her if she hasn't figured out gravity yet. And I've actually put a picture up here of André Kuipers. In my time at the Institute of Physics, one of my favorite things that I did was I got involved. This chap, he's a Dutch guy. At the moment that you can see on the screen there, he's in the International Space Station. And ESA, the European Space Agency, had sent out a whole shed load of these things, which are experimental packs across the whole of Europe. And then they got people from across Europe. In Britain, they were in the National Space Centre and so on, to do an experiment at the same time as André Kuipers to prove the difference between what happens on the Earth and what happens in space. So there you can see I'm holding the same device that he is. And what this is, I have very cold hands, so it doesn't work for me. But the idea is that you hold that like that, and you can see all those little bits inside it. And the idea is that as my hand warms, it starts a thermal current that way, and then it cools and comes down, and the whole thing starts going round. So for people with normal warm hands, that would happen. But of course, in space, André Kuipers was doing exactly the same thing, and there was no movement whatsoever because the thermal current didn't come to exist because they were in free fall. So let's move on to communications. That whole thing was an incredible feat of communications when you think about it. So the signal was coming down from the space station to Houston. It was going from Houston to ESA. It was going from ESA to all of the different, I don't know, whichever, Skype or whoever was hosting the communications. And then it was going to all of the different places in Europe and back again instantaneously. And I was standing next to a couple of kids at the back, and they said it's just like a Skype call, and they didn't really have an appreciation of the sheer mind-boggling logistics of communication that were behind that. Now, I've included communications, the Hitchhiker's Guide to the Galaxy, just as a little reference to the sub-ether wave band, because I couldn't do an entire presentation on science fiction without including it. So the sub-ether waveband alludes to the time before the Michelson-Morley experiment, when there was an idea that the whole of the universe was suspended in something called the ether, and if you could exit the universe, then the laws of the universe wouldn't apply, and you could get instantaneous communication across large distance. Other people have tracked it in other ways. The way I've been thinking of doing it, so you may not be surprised to learn that I have allowed faster than light travel in the universe that I've been writing in. And it occurred to me that the old French Napoleonic semaphore stations could be a way of expediting communication in that kind of environment. So they built these things on tops of hills, and they could see them over large distance, and then could read what happened. And they had, there's a picture of one for real, and they had a whole network of them across France. And you could get a message from Spain to Paris in less than a day just by sending these messages that way. And I think you could do the same if you did actually have ships that could travel faster than light. You could send your light speed communication to that ship from the planet, and then that ship could jump across, broadcast it to the next planet, or broadcast it to another ship who then jump across, and so on and so on. Other people have taken other things. One writer who I have a great respect for, is an incredible writer, is Ursula K Le Guin. Absolutely brilliant books. Her most famous and possibly the one that everybody says is the greatest is The Left Hand of Darkness, which is an examination of the ideas around androgyny, of all things. And The Word for the World is Forest also won a major prize, and that's about imperialism, and mainly about the Vietnam War, which was going on at the time it was written. But this is my favorite. This is the one that I really loved. For a start, the principal character is a theoretical physicist, and there are not enough books with theoretical physicists as major characters. But all of them, they talk, so she doesn't allow faster than light travel, but she does allow faster than light communication through means of something called the Ansible. And the Ansible was invented by the guy who is the principal character in this, and it's the story of that invention. So there are different communication methods that people do in it, tachyons and quantum non-locality and wormholes, ways of passing messages quickly through space. People make up words like ultrawave and hyperwave and tachyon-like. The Ansible she regards as being based upon large mass and the interactions of things between large mass. Psychic links, so Dune is an example where people can actually link up psychically through the universe in a faster than light way. My favorite little idea, from what I've read from the literature, it won't actually work, but my favorite little idea is the quantum entanglement idea that we've established. You know, if you quantum entangle two particles and you change one of them, then the other one will change instantly. And the idea is that you can have an 8-bit or a 32-bit, whatever, of these entangled particles, and then you take the other ones to the far side of the universe. Whatever you change in this one then instantly comes out as a change in the other one. It won't work, but it's a lovely little idea, and certainly one that fiction writers could run with a little and actually claim to have some kind of faster than light communication. And so we move into weapon systems. Once there's a breakdown of communication, wars inevitably happen. In my own book, so I have a background in police weapon systems, and so I let my imagination run riot. We writers can be quite sick people at times with the kind of things that we can come up with. Other people come up with sound, directed energy, explosions, psychological warfare. Not all are fictional. In my previous work in Less Lethal, I encountered microwave guns, ultrasound weapons, high density directed acoustics. But in my Less Lethal universe, I've got zapper rounds. They're like a taser X-ray. Stun grenades, puke grenades. If anybody's ever seen Six Sticks in Minority Report, they're things that make people become immobile through an uncontrollable urge to vomit. Asimov had a ubiquitous blaster, which was basically an atomic shredding device, very useful in if you want to kill somebody in a world of advanced medicine. But we can also look at weapons. One of the things that I came up with in my book in 2015 was the idea that a doctor can inject osteoprogenitors, I called them, into bones to aid with the knitting process of them. And I was absolutely delighted that on the 21st of September this year, King's College London published a bandage of bone-forming stem cells, sounding like osteoprogenitors. So that was, I'm chalking that one up as a victory of prediction. So there's also the idea of kinetic energy as a weapon. So this one is Footfall by Niven and Pornell. So I really like the other book that they wrote, but I really didn't like this one for a whole load of reasons I don't have time to go into now. Not least the fact that the aliens are two trunked elephants. But it will not be a giveaway, given what's on the cover of these books, that they start flinging asteroids at the Earth to try and subjugate us. Another thing is weapons systems in space, battles in space. There's this idea that ships, when you see them in things like Star Wars, they are close next to each other and firing, but it's entirely possible that they are firing each other energy weapons like lasers from very large distances at each other. And that's something that's dealt with in the sequel to The Mote in God's Eye, called The Gripping Hand, or in this country, The Mote Around Murchison's Eye. And that's the kind of thing that they're dealing with there. Of course, the reaction to this is shielding. Shielding in what I think should happen. So I created shields around my ships where you have a magnetic field. So this is the ship in the middle. You create a magnetic field, and then you have a plasma that is charged that squirts out of the front of the ship, follows the magnetic field around, and then gets sucked up the back. The plasma, one of its properties is that heat instantly spreads out through the plasma, and thus any energy that hits it, whether it's directed energy from a laser or something like that, is being absorbed. But the plasma gets hotter and hotter and hotter, and obviously black body radiation, you can see it, and it goes red and it goes yellow. And I have stolen some of this from the Mote in God's Eye as well. But eventually it becomes so energetic. Of course, this heat that comes back into the ship, you can use that heat, you can use it to power your ship. But eventually it will become so energetic that it will escape, and then you're at the mercy of your enemies. Again, I saw in March 2017, NASA proposed a magnetic shield to protect the Mars atmosphere, and we're also considering talking about doing it for the ships going to Mars to cope with that problem that we covered earlier with the solar flares. Now I thought, oh my goodness, have I got another prediction here? So I went to the literature and was rather miffed to find a piece of work from 1967 which predicted exactly that: the plasma radiation shield concept and applications to space vehicles. So sadly, NASA got to that one before I was even born. Now, the history of weapons has always been that weapons have the upper hand, or defensive weapons have the upper hand. So the First World War is an example of when defensive weapons had the upper hand in the machine gun. But the only science fiction that I've encountered where defensive measures have the upper hand is Dune, where personal shields can be worn which stop projectile devices. And so they've had to return to a world of hand-to-hand combat. Another form of shielding is, of course, cloaking technology. And there's all this stuff about, the Klingons and their cloaking devices, and people are working on this kind of thing, and we're getting very close to some very interesting materials that people have. But in space, as far as I'm concerned, we're already there, because in space, if you paint something black and you make it so that you can't see it with radar, and if you get rid of the engine emissions, how is anybody detecting this? Certainly from a long distance, how is anybody detecting these things? So I don't think that's a particularly, I think we're there with cloaking technology as it pertains to space travel. Another one that I wanted to get into, so I had a particular moment where I needed people to move around in the universe without being detectors, and they did so inside cargo containers. And so you can see these are the kind of things that are deployed at ports at the moment to find out what's inside lorries or inside shipping containers. And so I decided that that's X-ray obviously going through them. And I thought, wouldn't it be great if my people could stand inside one? And down one side of the shipping container are a whole load of X-ray detectors. And on the other side are a whole bunch of X-ray emitters. And then you have a big shield behind it here. And so as the X-rays come in, they all go into a computer. and then the computer squirts out the X-rays that are expected at the other side. But of course, you also want to say, if you're saying this thing is full of machine parts, then you don't want that person to be there, you want a machine part to be there. So this computer can then superimpose these pictures of machine parts onto that, and anybody watching it will then just see what they expect to see. So finally, we'll get into drive mechanisms just before the faster than light bit. The old traditional thrust is achieved through rocket fuels, oxidation. I'm not going to go into that now, we all know about that. The engine of the future, certainly if we're going to be sending a lot of stuff to Mars, is going to be ion drives. NASA engineers love ion drives. The chemical engine efficiency that we just saw in the previous one is about 35%. Ion drives actually achieve about 90% of efficiency. So they work by basically, I won't go into the full detail now, but they create ions here, which then pass through a magnetic field, and the magnetic field shoots this discharge plasma out of the back of it. So you are basically creating, the electrons are emitted by the discharge cathode ray, to the cathode in the middle, and they move towards the anode walls. As they hit the projectant ions that are squirted into the chamber, they knock off the electrons and thus ionize it, goes through the magnet, and then shoots out of the back. Now, the trade-off is thrust versus acceleration. Current ion thrusters can only provide about 0.5 newtons of thrust, which is the equivalent force you would feel by holding about 10 peak coins in your hands. They also have to be in a vacuum to operate, so we are just talking about interplanetary travel with these. So drive mechanisms in the motor in God's Eye. An interesting one they have there is the light sail. So in this one, you could, if you make a large enough sheet of very, very thin metal, you could use the solar wind itself to push this sail and drag things along behind it. In this one, they actually, the people who launched it also built a huge battery of enormous lasers so that they could shoot lasers at this and actually create the pressure effects on it to move their ship. In the Purnell and the Footfall book that I was talking about a moment ago, they used something called an Orion Drive. Now, this was something that they tried to get into in the 1950s and 1960s. The idea of what you do is that you have an enormous ship and you have this enormous metal drive plate and you shoot atomic weapons out of the back of it. And so the atomic blasts will push against this drive plate. And you have big springs on it as well, big shock absorbers, so that you don't get immediately hit by it. But the idea is you chuck out an atomic bomb and then rise on the pressure wave, and you chuck out another one and rise on the pressure wave. And they built small versions with conventional explosives that did in fact work. And there's no particular reason why this wouldn't have worked at all. And you could put everything you would need for a Mars colony on the top of one of these things. However, they did actually do some research to find out what the effects of the background radiation would be. And so all those atomic weapons that you use to actually launch the thing, the background radiation would have accounted for 3 lives for every single time you launch it. Now, you could say 3 lives, what's that out of 7 billion? Especially when millions of people are dying of coronavirus. But if you change that and said, every time we launch a rocket, we're going to shoot 3 people in the head, absolutely nobody would go along with that. So this Orion Drive is an interesting mechanism. It could work, but we won't be using it on the Earth. Alistair Reynolds in Revelation Space creates a small wormhole in time where they actually use the plasma from the just after the Big Bang as a source of thrust. But now we finally get to the question that's at the top of the lecture, to see or not to see. So I'm obviously playing with the letter C there, and I'm talking about those who write space fiction and allow faster than light travel and those who do not. So 2 who do not are Ursula K Le Guin in her series, the Ansible series, and Alistair Reynolds in Revelation Space. And there are certain consequences for that. The main one being that basically people who live and work in space become a breed apart from everybody else. And the main reason for that is time dilation. So let's imagine that you have a ship with enough fuel to constantly accelerate at 1g. And so 9.81 meters per second squared. When that ship launches, after 1 year, it will have reached 0.77 times the speed of light. But from the Earth, it will be 1.19 years have passed. And they'll have traveled about half a light year in that first year. So after 2 years, you'll be at 0.97 the speed of light. But instead of 2 years, on Earth, 3 3/4 years will have passed. That still isn't too bad. And you've traveled about 3 light years. And that's kind of the distance. You're getting towards the distance to some local stars there. After 5 years, you're at that speed. But although it's just 5 years for you on the ship, it's 83.7 years for anybody who's actually observing from the Earth. And you've traveled about 82 light years. So we could be exploring the local star cluster at that point. 8 years, you're traveling at this speed, but now on the Earth, there's been 1,840 years past, and you'll have traveled roughly that amount of light years. So now you're getting up to those kind of speeds, but anybody that you knew when you left Earth is already dead before you get anywhere. And let's remember that you need to switch over about halfway towards where you're going and decelerate the time as well. But after 12 years, you could travel pretty much across the whole of the galaxy, but 113,000 years will have passed on the Earth in the time that you're there. So as far as I'm concerned, I'm with these chaps, and these are the ones who say that you can have faster than light travel. In this one, it's a jump, it's not explained. In this one, there are portals, so you have to travel subluminally to a place, install a portal, and then you can have immediate travel. In this one, there are navigators who can fold space, and in this one, there are specific points in space that are connected to each other. So what am I doing in mine? We've all got to make up a new one, haven't we? So as far as I'm concerned, a gravity potential well, at this point on that gravity potential well, you have the most rapid change in the gravity field. And I've decided that that is an unstable point in space. And so my ships carry particle accelerators. So they have these particle accelerators, and I've played with the idea that if your particle accelerator is powerful enough, you could create little black holes. They are supposed to just evaporate in a puff of Hawking radiation as soon as they're there. But this is fiction, after all. I am going just a little bit beyond physics in my fiction. And so, as far as I'm concerned, you can fire these black holes at these unstable points to rip open a hole in the fabric of space-time and create a wormhole. Now, obviously, to have these big particle accelerators, you need big ships to put them in, and there it is in a big ship. And you can also use those particles to shoot out of the back instead of an ion drive. So you can use it for both firing these black holes to open these things and also shoot those out the back. Now, if you wanted to, the actual space that a human would need to inhabit in one of these ships would be very small. Now, again, in Napoleonic times, they had ships, fast ships called sloops, that were specifically to take messages back and forth. And so they were tiny ships, but very fast. And so I had this idea that you could have these tiny ships that are very fast, but you still, if they're going to go anywhere, they still need these particle accelerators. So you've got this tiny thing and the particle accelerator around the outside. And so you can just connect these with the skin of metal. And there's no real reason why this bit in the middle needs to be square. So let's go ahead and make that round. And that's the moment I realized that despite all of my problems with pulp science fiction, I had just entirely recreated the flying saucer. So maybe I am a pulp science fiction writer after all. And that's our little journey from beginning to end. I hope everybody enjoyed it, and I will be very happy to take any questions that anyone has.
Thank you, David. Well, we haven't had any questions submitted yet, so please do go ahead. You should actually, sorry, there we are. I should be on there. There we are. So David here is monitoring your questions.
I'm absolutely bursting with questions myself. So
I'm gonna switch off now and let David take over, and he's going to ask his own questions. And while he's asking that, please do type away and ask your questions of David, and I'll shut up.
Thank you. First of all, David, that was absolutely wonderful. So thank you very much for that. I'm afraid I got kind of lost in reverie for the first sort of 10 minutes because you mentioned Harry Harrison, and all I could think of was Bill the Galactic Hero. Couldn't really listen to what anyway. But I was also fascinated and vastly amused by the captioning that was scrolling along the bottom of the screen, which are the two highlights from that. The first was the Lord of Physics kept cropping up, and I can't wait for somebody to write a book about him. And the other one was when you were talking about Ian Banks and the Culture series. That got rendered as somehow as the AI turning into Colchester. I found vastly amusing. Anyway, the two sensible questions. First of all, as a writer of science fiction, is it the case now that the frankly unbelievable parts of quantum physics render it more difficult to actually write science fiction because reality is so unbelievable?
I mean, I have to answer this, being a physicist who is absolutely terrible at quantum mechanics. I did 2 courses of it at university and never really got into it. It was never my bag. I think the problem is arising. So quantum mechanics is finding very unusual things, as you say, things that are counterintuitive, things that don't make sense on a common sense level, even though they make sense in a universal level and a mathematical level. And I think one of our wider problems is the field of what people call metaphysics. And people are taking these ideas, these things that are being found in quantum mechanics, and taking them to places where they don't really end up. You know, they're putting a big dose of woo on the top of it, and we're ending up in those kind of places. So I think any science fiction author that is really trying to grapple with the quantum mechanics, very best of luck to them. You are a better man than I, or a better woman than I, to deal with that. However, the thing that we have to take with a pinch of salt is any conclusions that people are getting to from the unusual parts of quantum mechanics.
Frankly, I take anything I read in a textbook with a pinch of salt anyway, but we're getting some questions in from the audience now. So the first one is from a chap called David Walesby, and this chimed with me. He says, I don't remember Ringworld, the Larry Niven book. Mind-boggling idea. Do you think that might be possible to build
I'm afraid I have no knowledge of that, Dave. So if you know what it is, would you like to comment on that one?
It involves a defunct civilization that constructed a ring of steel or some other material around the outside, in orbit around a star of a sort of planetary orbit dimension.
I hear, yeah, this is a Dyson sphere, isn't it? Is that what it's called?
Well, it's not. No, Dyson sphere is a complete sphere. This is simply a ring of finite width, rotating around the star. There are various other bits and pieces which I can vaguely remember now, but yeah. But the whole point of the book is that the alien civilization is long dead or disappeared, and so the travelers have to try and figure out how it was done and what it was for.
I mean, those things are incredible. I put that one into the same category as an orbital elevator. So these things, these are great ideas. So in addition to that one, this is the same idea around a planet. So if you can put a satellite into geostationary orbit above the equator of the Earth, then there is actually an idea that you could run some cables from that geostationary satellite and down to the Earth, and you no longer have to launch ships up there. You can just put all the cargo and everything you need onto that.
Arthur Clarke wrote a book about that.
Yes, and these are wonderful. And I would love humanity to get its act together and stop being idiots and start putting some real effort into things like fusion, things like the idea of unlimited solar power, things like space elevators. I just wish we could get on with that kind of thing and stop spending all our money on ridiculous and weapon systems and everything else. So yeah, I would love to find out if these things are real.
David Walesby comments. David Wellesby comments that you have to read Rig World.
Right, yes. Actually,
put it on your list.
This is the second time this has come up in one of these lectures, so I'm thinking I probably should. I have just finished H.G. Wells' The War in the Air, and particularly how Mr. Bert Smallways fared while it lasted, which is quite a mouthful. I think it's usually shortened to The War in the Air. So I've just finished that one, and I'm looking for something else. So I think that will probably be it.
Fine. Question from John Mulby, the one you started with, the Amazing Journey of Spaceship H2O. What age range do you think that is aimed for?
Well, my children certainly started enjoying it at the age, because you can just read out. You don't have to read all the details and everything. They just love all the pictures and everything else, and you can certainly start reading that to a 2 or 3 year old. I think they start to understand what's happening probably about the age of 5. But if you can get it so that they love it when they're very little and don't understand it, but always ask for it, then you can start to reveal things to them about the plot as you go through as they get older. But it's such an absolutely cracking interactive book that it's a great way of introducing the idea of science fiction to a very young child indeed. Okay.
That's Helen Child wants to know, how important is it to you when you're reading a book? How important is the science to your enjoyment? Can you enjoy bad science?
I can. I covered a couple of those in the Strugatsky brothers ones. The Doomed City. Just if I stop and think about science, drives me mad. If it's a bad book with bad science, I can't bear it. If it's a mediocre book with bad science, it irritates me. But if it's a good book, I can put my physics brain to one side for a minute and just enjoy it for what it is, a really well-written book.
I found it's often no less believable than some of the coincidences that occur in detective novels.
Sadly, my second book is actually also a detective novel, so it's okay. Sci-fi noir. But there's a long tradition of that. The detective story is a great story that a lot of people like, and can be an access point into science fiction as well.
Okay, one more from me, and I think we're about done. Sorry, we've got one more come in here, but just let me ask you mine first while I read what the audience is saying. What's the best or the worst prediction that you've come across in the novels you've read?
My favourite, very good prediction. So in a book that was written in the 1970s, I think. Hold on. In The Mote in God's Eye, written in 1974, they're going into a conference meeting. And so everybody walks into this conference room with a little handheld computer. And all of the information for that meeting, all of the notes, minutes, and everything else is in the central computer. And as they walk in, it downloads into their devices. And then they all log in on there, and everybody's recording it. And everybody, if they want to show something on the screen, they just mess around with the thing in the hand, and it appears on the screen and everything like 1974, they wrote that. I read the book in 1990-ish, and I thought, wow, I hope I see that in the future at some point. And we're already well and truly there. So yeah, that is my favorite prediction.
And I've spent 40 years in IT, and I tell you, no, you'll never see that. Nobody will ever get that together.
Yeah.
And it would work in the demo, but for your first conference, it would fall on its face.
Yes, yeah, that's the kind of thing that would definitely happen.
Yeah. Jonah McCaffrey has been listening to you, and she wants to know if you've seen the book or read the book. Or sorry, Jonah, yeah, he or she. Sorry, apologies, Jonah. If you've read the books or seen the series, what's your opinion of The Expanse?
I am very sorry, I've never read The Expanse. Very sorry about that. It's such one of the wonderful things about science fiction is there is always more to read. And I've been to the World Science Fiction Convention twice now, and so I'm there with my publisher, and we spend 4 or 5 days on the floor, the trading floor, and all that kind of thing. And speaking to science fiction fans never gets dull. Everybody has read something you haven't read. Everybody talks about it. If you ever get the chance to go to the World Science Fiction Convention, go for it. I believe there is a chance it might be coming to Glasgow in a couple of years' time. So they organise these things a couple of years in advance, and I think it may be coming to Glasgow. And any of you who love science fiction, you can get there. And I am sure, Jonah, you will find somebody who has read The Expanse, and you will be able to discuss it extensively with them.
Excellent. Well, I think that's about it. So, yes, I'd like to hand you over to the young lady sitting next to me, my wife, Margaret, who I think is going to propose the thanks to you. All right, John?
Hi, thank you very much, David. I think it's time I read your first book again to get the science right, and I will buy your second one. Fantastic. I don't think I've actually taken into account all the physics when I've read the books, but you've really opened our eyes to it and our understanding. So as we hopefully the vaccine is not going to be science fiction, so we may not have a long time to read books, but it's something we can do. We can get ordering books now and read quite a few. Well, those of us who are privileged not to be working. But finally, did you ever read the Lensman series?
This is making me look like such an ignorant person who's never read.
I read those in the 70s, so you were very young then. So, but anyway, thank you very, very much, David. That was so entertaining, and I think we'll all go away and do something about what we've heard from you. Thank you.
So, yeah, so all of it's on that reading list. Feel free to read all of it and disagree with me incredibly. Right, thanks very much indeed.
Thank you much, David. If I can just put up a slide that I should have put up right at the beginning, just as a parish notice, hopefully this will work. Says he, hopefully. Right. So David will give me a thumbs up if you can see a slide. No.
You can see that.
Yes, you can.
Yes,
right. Okay. So I was just going to say these are the upcoming events, not just for the Hereford and Worcester Centre, but for the West Midlands as a whole. So because we're not so geographically constrained, you're welcome to join in any of these lectures. The next one of which is about, it's got an interesting title about bagels and pastries and topological phases of matter. So it sounds like it's a bit of a slightly fun lecture hosted by Birmingham on the 17th of November. There's also one that Wolverhampton are hosting on the 18th of November, as you can see there, about vortex dancing with structured light. I don't actually have the press of that one, but that sounds great. In terms of our own centre, we've got our very own David Cross, who you've already seen, who's going to be talking to us about physics and to the climate rescue. That sounds absolutely fascinating and very topical at the moment. And then again, another Wolverhampton one in December on the 16th. Can we photograph the Big Bang? And Kiel are giving one on the 17th of December. What are you made of? So just notice that the Wolverhampton one's in particular at 5 o'clock, which is much earlier in the evening, and the Kiel one's at 7. Otherwise, we're all at the same time. In terms of our lecture programme, it's been on the handout. You should be able to see that. Obviously, as the situation with the coronavirus has developed, we're now forecasting that we're going to carry on doing these webinars probably until at least March. So that's slightly contrary to what it says there, but we'll hope to see you all online, and hopefully we will start face-to-face meetings as soon as we possibly can. But obviously, that's not certain at the moment. I'll stop sharing my screen, and all I can do is thank everybody who's joined us this evening, and thank again David for giving us a really interesting talk, and we hope to see you all again on the 9th of December. Thank you. Bye.
Yeah.